Hi guys. Okay, so let's look at the concept of percentage yield. Percentage yield by formula is actual yield over the theoretical yield times 100. Okay, so what is a theoretical yield? Theoretical yield is the amount of final product that you would obtain in grams from a certain amount of reactants in grams, and how much of that final product will be obtained is determined by the limiting reagent. Okay, so that is the theoretical yield. Theoretical yield is not the real yield. It is only a calculations that you have done, let us say, on a piece of paper. And this is not a reality, but it is just in theory. We expect the final product to be in that much amount. But the reality is the actual yield, which you get in your hand after you have finished all the different steps in that synthetic process. Okay, so actual yield is the one that is going to be always lower than the theoretical yield, unless there is some impurity in the actual yield. But in reality, the actual yield is going to be lower in amount. And why is that so? Because when you're doing a reaction, and particularly a synthetic reaction, you're trying to synthesize something, then you follow certain steps, right? You follow certain processes. And for example, you will be taking the weights. I mean, that's always given. So you will be taking the weights. You're going to be doing the analysis somewhere in the middle to determine whether the reaction has, how far the reaction has progressed, or is the reaction complete or not. Then you are going to do some kind of transferring of the solutions or the reaction mixtures. You will be doing filtrations. You're going to be doing isolations, right? You're going to be doing some kind of purification. So all these processes and many more, and a few of them are just coming in my mind, is, for example, distillation, right? Crystallization, right? You may be drying the compounds. So that's all these different processes, depending upon what you are synthesizing, are going to eat away your final product. In other words, there is going to be productivity loss. So when there is a productivity loss, that means your final yield is going to be lower. Okay, and that's fine. We just want to know what that percentage value is from the percentage yield. And the value of this is that it helps us determine and make decisions regarding our step. So when we are synthesizing things on a very large scale, where we have so many other parameters also come into play, such as in manufacturing, certainly productivity cost is a big factor there. So we want to make sure that we get the maximum amount possible from whatever steps we are using in that synthesis. So looking at the productivity yield, we make these decisions. Should we buy a new equipment? Should we change the apparatus? Should we reduce the steps? If we are reducing the steps, then what other synthetic route are we going to follow? So chemical engineers use this information on a larger scale to, sometimes they do modify the steps, synthetic steps, to make the final product. Okay, so this is the whole idea behind the percentage yield, because it helps us to analyze our steps, and we want to get the maximum yield possible, and it helps us to bring efficiency in our steps, in our chemical reactions, and bring in the synthetic processes. And overall, on a large scale, we want to have the maximum efficiency and the maximum yield possible, okay, in our processes. So that's where the use of percentage yield comes into play. But let's look at it in one of the reactions here. How are we going to calculate that? Okay, so just hang in for a minute. Okay, so now let's look at the problem here. in which we are going to determine the percentage yield. So first we will be obviously determining the theoretical yield. So what is given to us here? So we are looking at the lithium hydroxide, and this is reacting with a large excess of carbon dioxide, and this is giving us lithium carbonate. Now, what is given to us? We are given 72.8 grams of lithium bicarbonate that is being produced. That is the actual yield of lithium bicarbonate that is produced when 50 grams of lithium hydroxide reacts with a large excess of carbon dioxide. So the question is asking us to calculate the percentage yield. Okay, now here they have not mentioned that calculate the theoretical yield, but for this formula, you need that. So that is why you would be doing a calculation regarding the theoretical yield. So first of all, for the theoretical yield, the simple steps to get the theoretical yield are you're going to take the grams of one of the reactants, which is the limiting reactant. And in this case, we can clearly see because carbon dioxide is in large excess anyways. So lithium hydroxide, you're going to take that and you're going to convert it into moles using the molar mass of lithium hydroxide. So at this stage, I'm assuming that you already know how to calculate the molar masses. I'm not going to go into showing you how to calculate the molar mass, but the molar mass of lithium hydroxide is already calculated to be 23.95 grams per mole. Okay, using that, you're going to get the moles of lithium hydroxide. Next, looking at a balanced equation, we are going to do a mole to mole ratio, and we are going to get the moles of lithium bicarbonate. Okay, once we get the moles of lithium bicarbonate, you're going to convert it into grams of lithium bicarbonate using the molar mass of lithium bicarbonate. Again, formula for the lithium bicarbonate, LiHCO3, gives you the molar mass 67.96 grams. Okay, so that is first thing you're always going to do is calculate the molar masses. Okay, now the next thing is you're going to set up the problem. So here we are given the 50 grams of lithium hydroxide, and you're going to use that to convert to moles. So 50.0 grams of lithium hydroxide. First step is to convert it into moles. So we know that 1 mole of lithium hydroxide is equal to 1 mole of lithium hydroxide is equal to 23.95 grams of lithium hydroxide. Okay, and then you multiply it by the mole to mole ratio. So in this case, we see from this reaction, 1 mole of lithium hydroxide is reacting with 1 mole of, is reacting to produce 1 mole of lithium bicarbonate. So it's 1:1 ratio. But if you had whatever coefficient was here and whatever coefficient was here, if it was not 1 but something else, then that just make sure that you put that in the mole to mole ratio. Okay, so we see that 1 mole of lithium hydroxide is reacting to produce 1 mole of lithium bicarbonate. Okay, so this is your lithium bicarbonate on top because you want to convert the moles of lithium hydroxide to lithium bicarbonate. Okay, the next is this step here. Till here we get the moles of lithium bicarbonate, but we are going to convert it into the grams of lithium bicarbonate using the molar mass of lithium bicarbonate. The molar mass of lithium bicarbonate is 67.96 grams, and that is LiHCO3. So that is the grams of lithium bicarbonate, and 1 mole of lithium bicarbonate, that is the this is basically the grams to mole, the molar mass of lithium bicarbonate. Okay, so next we see that grams of lithium bicarbonate and the grams of grams of lithium hydroxide and the grams of lithium hydroxide cancel out. Moles of lithium hydroxide and the moles of lithium hydroxide cancel out. Moles of lithium bicarbonate and the moles of lithium bicarbonate cancel out, and you are only left with the grams of lithium bicarbonate. Okay, so next is you're just going to do the math, which is 50.0 times 1 times 1 times 67.96 divided by 23.96 times 1 times 1. Okay, now let us say the question is asking you very specifically to use the significant figures, and in general you should. So let's look at these rules regarding the significant figures. Whenever you are multiplying or whenever you are dividing, at that time the lowest significant figure that was in the computation is going to be in your final answer as well. So here we have three significant figures, and ones you ignore. And then here you have four significant figures. And here also you have four significant figures, and then the ones you're ignoring. So your final answer here is going to have only three significant figures, and that comes out to be 142 grams, okay, of lithium bicarbonate. Okay, so here is going to be your, your three significant figures. That's one step. Next, we got the theoretical yield, but now we need to find a percentage yield. Okay, so the percentage yield is equal to actual, this is given to you, divided by the theoretical, which you just now calculated. So just remember that in the percentage yield problems, for the most times, they don't give the theoretical yield. So this is what you need to do in order to find it, okay? And otherwise, after that, it's easy. Okay, so we got the theoretical. This is now the theoretical yield. Let me change the color. This is the theoretical. So we found the theoretical yield, and now we are going to just put this 72.8. So here is your 72.8 grams. Oh, let me put it down here. I need space. Okay, so here is your 72.8 grams over 142 grams times 100%. Okay, times 100%. Now here again, you have, these are the three significant figures, and these are also three significant figures. So your final answer should also have three significant figures. Okay, so the final answer here is you are going to get is 51.3%. Okay, so 51.3% is going to be your final answer with three significant figures. Okay, so you just write that, and this is how you calculate the percentage yield. And I explained to you the value of it in the industry, where this is being used to make the processes efficient, you know, so that you can max out on the final product. That is what you need, with the less amount of expenditure in time, in labor, in you know, steps, and you know, overall, just overall less budget and more productivity. So that's where the percentage yield is being used. Okay, so I hope it was easy, and thank you for watching.